graph the function f of x is equal to negative the cube root of x plus 1 plus 3, and state its transformations, find any intercepts, and find its domain and range. And so here, I'm just going to compare this to the general form of transformations for a cube root, a being the vertical stretch, b being the horizontal stretch, h being the horizontal shift, and k being the vertical shift. Now, a, even though there's no really a value, but you can see there's a negative sign in front, which means a is negative 1. And if a or b is negative, that means we have reflection. And a being the vertical reflection, so what this means is any y coordinate is going to become negative y, so it's going to flip the y coordinate, which means that it's going to be reflected on the x-axis or over the x-axis. H here is negative 1 because x minus negative 1 would be x plus 1. That's our original. So it's negative, so it's 1 unit to the left being shifted. K is 3, and so we're shifting 3 units up. And so now we can compare coordinates from the original base cube root function to our new transformed function. And you can see how we compare this is x becomes x minus 1 because of the shift left. Y becomes negative y. Once again, because of that reflection on the x-axis, y coordinate becomes negative y. And plus 3 because of the shift 3 units up. So I plug in our original coordinates. I plug it in for x and I plug it in for y. And you can see I get negative 8, and it becomes negative 9. All of these are subtracted by 1. Here, this will become, if I plug it in, say negative 2, I'll get 2, positive 2, plus 3, which is 5. You can see I did the same for the rest of the points. So now that I have these points, I can plot it on my graph and see negative 9, 5, that's all the way up here, negative 2, 4, negative 1, 3, 0, 2, which is right on the y-axis, and 7, 1. And you can see how, if I actually compare this to the original cube root function, you can see it's been flipped vertically. So instead of going down and to the left, it goes up and to the left. Instead of going up and to the right, it goes down and to the right. And so that's what the negative sign in front, the vertical reflection, or you could say, or reflection over the x-axis, that's what it does. Now, as for intercepts, well, we actually have the point 0, 2, which we already know is the y-intercept. We plotted that. But you could also, once again, just plug in 0 for x, solve for y, and you would get 2. So that would be your point. Similarly, if you plug in 0 for y, we're trying to find the x-intercept, where it intersects the x-axis. It looks like it's going to intersect maybe somewhere out here if I extended the axis. Plug in 0 for y, and solve for x, move the 3 to the other side, get rid of the negative sign, and then cube both sides. This 3 cubed is 27, and then I subtract 1 to get x equals 26. So the point 26, 0, that's our x-intercept. And you can see if I go way out here, it's eventually going to touch the x-axis. And the domain and range, oops, forgot a bracket here. Yikes. The domain and range for this function, because it's a cube root function, you can plug in any x value, it doesn't matter. And you can also get any y value. So the range and the domain are both from negative infinity to infinity, or x is all real numbers and y is all real numbers.